Well, good afternoon, everybody, and welcome to another exciting webinar with Regal. I'm Josh France. I'm joined today by Mike Cook from TopoDOT. Hi, Mike.
Hey Josh, how you doing?
All right, we got the first barrier of any webinar out of the way, making sure both hosts can actually speak to each other. So that's a good start. So we'll wait a few more minutes here to let everybody, or a few more seconds to get started here. Let everybody get time to settle in and wake back up and see that we're ready to start here. So today we're going to talk about power distribution lines from a mobile mapping perspective. And I know a lot of folks are saying most of the time in their heads, mobile mapping or power line mapping is usually done by airplanes. But there's a lot of information that's really critical for utilities that can be gathered right here on the ground. So let's get started. So quick overview of where we're going today. We're going to start with a brief introduction so you can learn a little bit more about Mike and myself, in case you don't already know. Then we're going to get into utilities mapping 101, so to say, talk a little bit about all the sensor technology that's out there, get into the most important thing about collecting data from a mobile platform, setting the settings correctly, and then we'll jump right into TopoDOT with a full-blown introduction to all the great features that can be extracted. So I'm the business division manager for mobile laser scanning in North America, and I bring a lot of years of experience. I've trained many folks out there on VMX operations or VMQs. And Mike is joining me from TopoDOT. He has a lot of experience as well, extracting great value from the data. So we should have a lot of good pointers and information to share with you today. All right, so utilities mapping. So here's a large look at the whole utility infrastructure on one page, right? So all the way from the power generation station through the transmission lines and to your home or office. And you can see there's a lot of different types of power transmission devices, a lot of different breakers, switches, lots of things going on in this graph. Now we even have a lot of lines that are buried underground, especially in Florida, all the new neighborhoods, all the power lines underground. But there's still access points from when that happens, right? So there's a lot of information that needs to be mapped out. And as America expanded and got settled, different setups were done by different power companies, and there's not necessarily a uniform mapping standard as to where everything's located. So as we're looking towards our new century here and our new modern era, the way people use power is changing. So when they first set up our power infrastructure, there was no thought that someone might have an electric vehicle and maybe that the whole neighborhood would have electric vehicles. So there's a lot of effort being put into developing the grid again, or redeveloping and redesigning it and adding more features to it, along with just typical things for management, such as making sure that the trees don't knock over power lines during storms, looking at hardening the infrastructure, whether it's from a temperature standpoint or natural disasters or just where it's been located on the earth in terms of the ground settlement. So there's lots of different things that need to be pulled out, and everyone wants to properly identify these assets that are on these poles, whether it's the pole tag, how many different cable lines have been run along there, or internet DSL lines from many years ago. And it's the Wild West of it in a way, because once the line goes up, people can't monitor them 24/7. And so different features and utilities tack on stuff. So there's a lot of identification work that needs to be done for sure. And of course, another thing is billing for use. A lot of utilities provide power to all the different municipalities for their streetlights, but they don't necessarily know how many are actually there, and they get a certain they bill per pole or per streetlight, and sometimes those numbers don't line up right. So another great reason to look into asset management from the ground, because you can see power poles and utilities from a different angle. So speaking of different sensor technology and how to capture all this great information that we need to develop a responsive, actionable plan for improving our power grid, we have different ways to collect this information. So if you need to do a statewide collect of all the utility lines running out of a PowerPoint, or sorry, not a PowerPoint, but a power plant, that's more of an aerial asset to be mapped. On the ground, going through neighborhoods for distribution lines, that's more mobile oriented. doing a small site like a substation where you need to be on the ground because you can't fly there and you can't drive there, that's more of a static tripod solution. And of course, the UAV brings in its own unique set of parameters and certainly scan collection. So just briefly highlight each of those, and I'll refer everyone to our Regal Video Lab, which is available on YouTube. And you can see a lot of these presentations from my colleagues out there at Regal USA and from around the international community who have spent some time talking about each of those unique challenges for how to best acquire power line information from their platform. So aerial mapping includes both helicopter and fixed wing aircraft, of course. And here's an example of a VP1 pod mounted on a helicopter. Then we have substation scans. So this is from my colleague Tan Nguyen, presented a couple months ago on how you would collect a substation with a TLS scanner. And you can see all the great information you're able to get by just walking around the outside with your scanner and setting up and taking a scan. So you're out of the electrical fencing area. And of course, you would want to have permission to do this, I might add. But for more information on how to properly scan a substation, please look at Tan's online presentation. So then smaller sites are great for doing UAV. So not only can you do some site planning analysis with it, but you can also collect great power line data. It also helps that you have different look angles than you would traditionally have from a airborne. Most airborne sensors have a limited field of view of about 60 degrees, looking straight down, so that's plus or minus 30 from nadir. But a UAS system can sort of fly alongside the power lines and capture it at a different angle. So you get a different density, and it's great for small site planning where launching a full-blown aerial mission wouldn't really be cost effective. And my colleague Mai-Lin Trong has provided us with some great information in her webinar on the benefits of the BUX-1 series scanners. So now we're getting into the mobile. So we have 3 different systems that you can use to collect mobile data. We have the VMX2HA, of course, and you can see we have cameras set up there with a swept back look where we'll be able to collect more power line information. We'll talk a little bit about that in a moment. You then have the VMQ1HA, which is our swivel plate single head solution. So you can turn it to different angles to get different look angles at the same data set when you drive it multiple times. And of course, our newest one, the VMY2, which is a dual head system made up of mini BUX scanners. So now we're getting into the meat of the program here. So mobile data capture. What are the big considerations when you say, I'm going to go out and collect some power line data? Well, the most obvious one, of course, is you need to plan your route. So if your goal is to collect the whole neighborhood, you probably need to drive all of the streets in order to collect the data. We do have good ranging. However, the angle that you would actually see the power lines is really best right next to it on the roadway. So as you can see from this quick screenshot, there are some power lines and poles that are behind the houses or buildings there, but the majority of them are right near the road access point there. And you can see the trees on the far end there are starting to encroach heavily on that power line to the point where they would definitely need to be trimmed back. And it looks like in the past they have been, based on that interesting pattern of leaves there. So route planning is a big consideration. You need to go where you need to go, and then you need to allow some flexibility to account for the fact that power lines may run in a different direction from the last Google Earth image that you last used for your planning information. Then, of course, you got to talk about ISG and SS solution. So this comes into play on what overall accuracy you're looking at for your overall collection. Are you going for 2 meter, 3 meter accuracy, or are you looking for something in the centimeter or millimeter level range of accuracy in terms of your absolute georeference location in the world? And so if you're looking for the highest possible accuracy, you're going to want to make sure you get a really good IMU that goes with that mobile system. Next, you got to talk about laser sensors. So we make some amazing laser sensors and have lots of different features in them. So the VMX scanners, which is the BUX-1HA, have a 5mm accuracy with a 3mm precision and can pulse light up to 1,000,000 times a second per scanner. So you get a lot of really high density point cloud information, but you may not need all of that. So the VMY offers a counter to that where it has a 200 kilohertz per laser pulse rate, which is much less information per laser, and it would give you sort of a rougher sketch of the area as opposed to the really fine details that you see in the scan data here. And of course, you have to also look at beyond that, you have the benefits of the time of flight laser with the Regal sensor that collects all this great information, and we have a very good signal processing routine that keeps all the noise out. So this wasn't an edited picture where I had the crop for hours and hide all the dots that don't belong there. This is just the raw data post-process screenshot. So different systems produce different levels of data as a result. And then image quality. So a lot of what we're asking from, a lot of what we're being asked to collect from utility companies relates to information that can really only be seen by a photograph. Yes, you can see the electric lines, and yes, you can see there's some objects there, but not everyone can think in laser data. I mean, I'm getting close to it, but I'm not quite there yet. I still recognize things better in pictures. So that's why image quality is a big factor. And when you talk about image quality, you have to then think, how is it capturing the data, and how are we best going to utilize the image sensing capability that we have. There's only so many images that can be collected and saved, especially if you talk to your IT departments. They'll tell you that there's a finite amount of room for you to store data on, and they don't like being surprised by hundreds of terabytes of data from a single mobile collection, especially if you have really large high megapixel cameras. So when we were looking at our camera setup here, the key factors, of course, are how far away is the object going to be from you? What's the size of that object that you want to collect? So are you looking at a very small, 2-inch object, or are you looking at a 5 or 6-inch object? So knowing all that, plus how fast you will be driving, helps us determine what lens to pick, what exposure time to set, and what frame rate will help best capture this information to avoid pixel blur, particularly, and to actually let you get the right information. So with the VMX2HA and the VMQ1HA and even the VMY2, we do have an ability to add our Regal cameras, which are integrated housing cameras with 2 different megapixel options, but we're going to focus on just the 12 for today. And we have 2 different lens choices. So if we pick an object that's 30 millimeters away from the sensor, we can see that the image size in the center, so the pixel size, therefore, is 12 millimeters for an 8 millimeter lens and 6 millimeters on a 16 millimeter lens. So obviously the 16 millimeter lens will allow you to see smaller details further away than the 8 millimeter lens. It's basic camera focal length math there. And they also have different field of views as a result of that pixel size. So knowing what size object you're aiming for and approximately how far away it is will allow you to make sure you have the right lens choices. And then, of course, you need to pick the right orientation. So if you were going to collect power lines and you have all your cameras facing forward like this image is, you'd be looking for power lines really far in the distance and not necessarily right next to your vehicle. So angling and adjusting the cameras to be the right orientation is really key for that. And of course, having enough cameras to pick up all the different possible orientations also plays a big role as well. So then what are the settings that we can control? Well, we can control the exposure time, the gain, and the image size, and of course, how fast we capture them. So just a quick brief reminder that we do have published recommendations for all Regal cameras based on various lighting conditions. So if you have an overcast day, those are the settings you want to choose. They're related to the auto maximum gain, the maximum, the exposure target percentage, and then the gain, and that's sort of what makes the pixels look grainy, if you will, since gain's not always a common word that everyone's familiar with. And of course, we also have the ability to go into a 12-bit depth range for each of our images to get even more information extracted out in post-processing using our automatic brightness tools. And so we also have these recommendations for sideways looking cameras as well. So overall, on the mobile acquisition side, we have the ability to change the angles of the data. We're able to brighten the images and post-process is what this image here is an example of. And we're able to really focus in on what we want to see. So we have all those tools, but now we need to see how we pull information from that. And that's where I'm going to pass this off to Mike. And we're able to export out a RIE process ready to go for TopoDOT data extraction. Mike?
All right. Thanks, Josh. And hello and welcome to everyone out there listening. In this segment, I'd like to introduce you to TopoDOT and the solutions that we provide, as well as help you kind of navigate the opportunities available within the power and distribution space, essentially using LiDAR data. Josh introduced me earlier, so I'll keep this short. My name is Mike Cook. I'm the Senior Applications Engineer over at TopoDOT, and I've been here for 10 plus years. And I'm not alone. We have a dedicated team to help support the TopoDOT community. We are a software development company, but we also provide training, support, and consulting services on top of that. And we want everyone to know there's a lot of point cloud data coming our way and currently out there. And many organizations and engineering firms have joined this TopoDOT community to provide the best geospatial services they can for all of the downstream operations demanding this. Our community has existed for 30 plus years, now with over 500 plus companies worldwide and with over 5,000 individuals utilizing TopoDOT. TopoDOT is a industry-leading software application for extracting high-quality topographies, 3D models, and assets from the point cloud data itself, which feeds downstream operations across multiple disciplines, including the electric and power sectors. The primary application areas for TopoDOT include the following: transportation corridors, both rail and roadway, the electric and power corridors for transmission, distribution, and substations, as well as bridges, tunnels, and general structures. I'll just go ahead and skip through part of this video here just so we can kind of see a flavor of all of those applications. But our focus today will revolve around strategies for extracting distribution lines and utility poles. So where do we fit in to the big picture? Essentially, data is going to be collected and registered at the system level, which is where the pink bubbles are. This includes static data, mobile, and airborne data. From there, the exported point clouds will feed into the TopoDOT process, which are going to be the green icons. And I'll note here that Regal's data sets are pretty much fully compatible with the TopoDOT environment. So you should have no problem bringing their data in. And here we offer a complete and comprehensive workflow to help manage your data, assess it, and essentially extract that value from your data into a format of your choice. So this process is a process that we've set up to help you, get the deliverables that you're looking for. First, a quick look at our agenda. I've already given a brief introduction, but I'll dive into three main topics: the type of projects out there, essentially all outside plant infrastructure, the types of solutions offered to handle all of this point cloud data, and essentially the big picture, collaborate across your organization and extract what you need, as well as where and when you need it. Just remember that data is at your fingertips. You might not be the actual CAD tech or any running the extraction process, but it is there, whether it's through a dashboard or in a CAD environment. And just like Josh pointed out earlier, there's a lot of stuff out there, so a lot of opportunity. And the electrical grid can be considered one of the largest machines on Earth. As long as the feature that you're looking for is large enough and is no smaller than the spacing of the data points and or the pixels of the image, we'll be able to extract the majority of these items that we see here. So let's take a closer look. So what features am I talking about? This is just a quick list of what you can extract, which includes towers, poles, wires, attachments, clearances, the real estate on or between, the power and communication space, encroachment, sag points, footers, etc. The majority of the larger objects can be extracted using the point cloud data alone. And for the smaller objects, these can be identified using the high resolution imagery. And essentially the imagery is going to complement the point cloud data as we look at this. And we'll see one of those images in a moment. What we're looking at here is a mobile data set from a Regal mobile system. This is a dual head scanner configuration, which is going to give us plenty of detail. And keep in mind, this is from a single pass only. So if it doesn't necessarily need control, especially if we're doing a bunch of relative measurements, it just cuts down on registration time too. But with that single pass, we have all this information. And what we're seeing is there's two elevation views of a shared pole. It's colorized in elevation, including the system's high-res image in the center. And again, the imagery is important because this will be used to identify the finer features, tag number, pole material, condition, etc. If you actually look towards the top, you can actually see the number on the pole marked as 74. So the imagery is great, while the LiDAR data is going to be primarily used for positional and dimensional information. Now, generally, mobile systems provide better detail and quality than the airborne systems, which is going to be necessary in order to extract what we see here, as well as all of the features that we mentioned previously in a previous slide. First up, we'll take a look at a substation. All data collection was done outside of the fencing, which ultimately is going to save time and money because there's no need to shut this down. And a typical scanner to be used here would be a static terrestrial unit, in this case a VZ400 or Regal unit or equivalent. And substations are generally the most complex to extract from because they have a variety of equipment, structures, a variety of wire lengths and paths, and this is all packed into close quarters. So in this scenario, it's key to have user-friendly tools to allow for optimal interaction with the point cloud and the imagery. So as an example, you just want easy navigation, a variety of cross-section tools, the ability to snap to points in a variety of ways, as well as loading images that you need when you're in this environment. Transmission lines, however, they're generally the easiest to extract from, and they're collected using airborne systems, whether it's a large aircraft or a smaller drone system. But the Regal instrument of choice here would be a VPX-1 helicopter pod or the VQ-1560, I believe Mark II for a fixed wing. But again, I've seen drones with a Regal head to tackle these as well. So they're easy because they're all isolated and spaced out. They have consistent wire structures with very little change, and they're fairly linear in nature. So automation routines can be applied to most transmission line projects due to this simplicity. Distribution lines, however, they're a bit more challenging and require more detail, which makes mobile ideal for this collection. The MLS unit of choice here would be either the VMX or the VMY2. And the reason why this type of project is challenging is because they're surrounding other features. There's trees, there's inconsistent wire patterns, there's complex wire routes and paths, you name it. So apply automation where you can, and then finalize with the necessary semi-automated tools to get what you need. And at TopoDOT, we're all about productivity, and it's important to understand the balance between automation and user input. There's more value in user-friendly tooling than there is in hands-off automation. Well-defined workflows and user-friendly tooling is going to allow any team to scale effectively. And when taking this information to another platform, you'll want flexible options for export, pull information and attribution into a shape format or a CSV or possibly a KML, or export the full model as a drawing file or a CAD file. This could be used for pull loading analysis softwares. A very common one would be PLS CAD. And for those who are just classifying data, you can export the point cloud a variety of ways, such as LAS format. And another trick is to creating a drawing sheet to help visualize your displayed work. And we could see that on the right. Let's take a closer look at wire and attachment extraction. So this is kind of a look and feel of how this stuff operates. The goal is to vectorize these lines and the attachment points with a few simple steps. First, we'll locate the poles or towers using an auto search. And we give it a few examples, and then from there, let it find the rest. And you'll check, add, and subtract as necessary. Once this is done, though, the power information is taken to the wire extraction phase, which is where we'll design a wire pattern or template that can be used repeatedly. This template can be used to automate the rest of the remaining wire spans. So what we see here is basically just that template going through and finding those patterns. Notice how the wires and the attachment points are being collected all at once. For the more complex scenarios of wires, we'll use tools designed to search individual spans. All the user has to do is basically specify a region of data, and from this, the wires will be located and vectorized automatically. So all they're doing is basically setting up a cross-section within that span, and the tool is kind of doing the legwork of finding those wires for us. Next, we're just going to simply gather or select the spans of wires, and we're going to use a routine to automatically connect them all. We essentially take all the wires and we're going to join them to their neighboring counterparts while also locating the attachment points. We'll see this in a moment here. Okay, so that was the connection process. Let's see how we can gather more information, such as information on the poles. So with the presence of the attachment points, we can actually just automatically locate the towers, which we'll see in list form. This will automatically center itself for each pole and determine radius at breast height. You'll get a top-down view with a horizontal data slice, and then two elevation views of the pole itself. And within this preview, you can precisely control tilt, height, top radius, and more. You'll notice the attachment points are also being displayed as well, which allows for a variety of measurements to be taken. So you can store these as offsets, or you can store the closest image, get relative vertical or horizontal distances, either to the ground or to the neighboring points. And again, all this information can be exported and or displayed graphically, but export options will be via shapefile or a CSV file. And with this approach, you can extract what's needed much faster than the traditional approach, reducing data collection per pole down to just a few seconds. Another approach for locating poles is to just perform an automatic search for vertical objects. This tool that we see here is going to build a list of vertical objects within an isolated zone. And in a similar fashion to the previous tool, the user will they'll be in full control over any inputs necessary. The synced images provide further clarity of the object at hand. Again, store the tilt, height, top radius images, etc. What you'll be left with is an attributed cell element that can then be exported through that shape file or CSV file. With the wires and poles extracted, you can use this now to perform an encroachment routine. Essentially, this will classify the data around the wires up to a specified radius. In this case, we have two zones to represent, and it's going to be an inner and outer region. The inner region is going to be yellow, and the outer region being red. With the data classified, we can then follow up with a clearance to cluster routine, which will basically find all the closest nearby objects to our wires. So you'll be left with a geolocated dimensional element there that we can see in the right-hand image. What else can we do with this encroachment data? At this point, it's just a point cloud, which has been classified into a specific class ID, or it's been binned into a specific ID. We can either save this to the existing point cloud or export it as a new one. That's one option. But sometimes delivering the point cloud is just too much data, or it's not compatible with downstream operations. Here we can see thousands, if not millions, of classified encroachment points. And in this case, you can consider a clustering routine, which will identify the clusters of the data and then graphically outline them. What's left is a simple shape element per cluster object. And we can see this in top view on the left-hand side via the red elements. You could further add information to this, like assigning attributes such as area or volume, and then send this to Esri or Google Earth. But this keeps file sizes down and becomes more compatible with those downstream platforms that you're going to. Clearances are pretty straightforward. You can gather the lowest at crown, as well as relative space between crossing wires. Simply select the wire of choice and the tool will just find it for you. And there's no need to clean up noise, floating points, vehicles, vegetation. Most of the tooling that we have is going to be filtering this type of noise on the fly. And remember the exporting options. One of them was to a sheet. This is just another way to convey field information and measurements, again, allowing us to reduce file sizes and become even more compatible with those other platforms. Remember, we can't always pass on the entire point cloud. And unfortunately, I won't be able to cover everything today, but what we see here should give you a general idea on what else is possible with your data. Here we focus on the applications of power lines. However, there will be other needs interconnected, I'm sure, such as topography and other asset information being requested from your design teams or clients. So why is all this important? It's going to allow for working remotely with ease of scalability. LiDAR technology basically is going to apply to all outside plant applications. They can also be applied to inside plant projects as well. And the extractive work that we get from this it's going to all be geolocated. We're going to see improvements to productivity, lower costs, repeat trips to the field. And what we're essentially doing is we're now extracting utilities faster than before, allowing you to turn a 30+ pull day operation into something like 300+ pulls per day. And extract value in minutes. That's kind of the push here is, imagine having access to data across your operations and direct communication with your data experts to extract what you need and where you need it. Okay. So if you have any questions, let's go ahead and talk. I'll leave you with our contact info. You can contact us by phone, visit our website, or email us. If you're into socials, you can find us there as well. I want to thank you for your time. Thank Regal for inviting me onto this. And now we'll turn things over to Josh now.
Well, we're right at our time of a half hour and a little bit extra time. Thank you all for staying with us today. If you have any questions, feel free to type them there and we can answer some live here on the air, or if we've answered all your questions, fantastic. Feel free to email us for follow-ups, demonstrations, and all the other great features that you might want to extract from your data, or anything else you might want to know about asset collection with a mobile system. All right, take a look at some of the questions that are coming in. As with all of our webinars, we do post these to our Regal Video Lab about a month to a week after, sometime in between there. So we will be making all of these available once again through our social media platforms. So make sure you follow us on LinkedIn and many other ones to get the latest and greatest news. And we do have a pretty large collection of amazing webinars on our Regal Video Lab. So Mike, this is a good question. So we have a question here of how user-friendly are the TopoDOT tools? Because it looks like it seems pretty easy from the outside, but what's your take on that?
Yeah, so usually we do like 3 training sessions with your team, and we'll get you up and running within a week or 2, and we'll tailor it towards your project types. So it's pretty intuitive. I'd say if you have a team with a CAD background, it's going to be even better. So I do recommend having a team with a CAD background. And there was a mention about cost. There is a link on our website on pricing. I don't want to throw out a number now because I don't know it right off the top of my head, unfortunately.
Well, there's a lot of complexities to it. It's not a one number fits all number, I'm sure.
Yeah, we have three enterprise licenses that we try to position to match what you guys are doing.
Yeah. From our experience at Regal, we know that our teams work the folks working in TopoDOT work very efficiently, very fast, and there's always something more that can be learned through contacting Mike or one of the other helpful support engineers at TopoDOT to review your current workflows and help you find efficiencies, as the TopoDOT team never rests, just like the Regal team doesn't rest either on making updates to software. And so, the feature extraction workflow you might have learned 3 years ago probably isn't the same anymore. Is that about right, Mike?
Yeah, it's constantly evolving. We're trying to improve things here and there, and sometimes we'll just do a complete overhaul. So it's definitely recommended to stay up to date, either with our webinars or contacting us, or
we're attending TUC, right?
Or attending TUC to come out and see both of us. Actually, you get to see the equipment side and the software side.
All right, well, that will do it for this Wednesday afternoon. Everybody have a great rest of your day, and thank you so much for attending. And Mike, thank you very much for helping me out and showing folks how to extract value from our data.
No problem. Thanks, Josh.
All right, take care, everybody.